Welcome to lesson 67. So today we're going to talk about anti-logarithms. That is just a fancy way of saying the answer. So the anti-logarithm is going to be the answer. Remember, here is the way we would normally look at it in exponent format. The 2 would be considered the base, and 3 is considered the exponent. Well, 8 is what we have been calling the answer or the number. This is the anti-logarithm. That's all that is. That's all we're learning today, is that this answer is actually called the anti-logarithm. So when we write it in logarithmic format, this is the base, this is the exponent, and this is the anti-logarithm. So it's really very straightforward. The answer is just the anti-logarithm. So let's look at some practice problems. So here we have 3 of our 5 problems. I think we have 5. Let me see, we might have... No, we just have 5. So let's do 3 of these. So the book recommends that whenever we have this... and I didn't finish writing the problem. That would probably be a good idea. Find the anti-logarithm of 4.63 with a base of 2, 10, and e. So the book recommends that we use estimation. And it says that what you need to do to make sure you have the right answer is to estimate the whole number on either side of this decimal exponent. So that means we would estimate 2 with an exponent of 4, which is equal to 16, and then 2 with an exponent of 5, which is equal to 32. So if we find the correct one, it should fall between 16 and 32. So what we're looking for is 2 with the exponent of 4.63. So to find that, we just pull up our calculator. And the reason we do this estimation first is to make sure we've typed it in our calculator correctly, because we're not going to be able to do this unless you're a genius in your head, right? It's going to be very difficult. So all we need to do is press our 2 key, our XY key, type in our exponent, and press equal. And our answer is 24.76 when rounded to 2 decimal places. So 24.76, and we just check. And it's after 16, before 32, somewhere close to the middle. This is a little bit more than halfway between 4 and 5. So I can accept that answer, and I know that that's correct. Mainly because the book also has the same answer. So let's do this one the same way. So we want to do, let's do 10 to the 4, which we know is just 1 and 4 zeros, right? And then 10 to the 5, which is going to be 1 and 5 zeros. So we want to find 10 to the 4.63. So it's going to be somewhere between 10,000 and 100,000, about halfway. So if we put that in the calculator, let me move this up. I'm going to clear that out really well. 10 xy, put in my exponent, and I get 42,657.95. And that's the correct answer. 42,657.95. That is correct. And you see it falls about halfway between here and here. So let's look at it with the base of e. That's a little bit more difficult. It's going to be hard to estimate this. We do know that e is worth like 2.7 yada yada yada, a bunch of stuff afterwards. So we can round it up to 3. So 3 to the 4 would equal 81, and 3 to the 5 would equal 243. So our number is going to fall about halfway between here and here, because we want e to the 4.63. So all we really have to do is pull up our calculator. And if you have one like mine, then you could press E, type in the exponent, and hit enter. I got that backwards. So 4.63, then press e to the x, and then it gives you the answer. Okay, so I had it backwards. Put in your exponent, press e to the x, and then hit equal, and it gives you the correct answer. So this 102.51. So 102.51. And if you have that type of calculator, you're just going to do the exponent. So you're going to do the exponent, then you're going to press e to the x, and then equal. And that's going to give you your answer. There's another way to do it. Let me see if I remember how to do that. Let's see, that's E. Yes, if you have the E key, you can press E and then the X to the Y and then 4.63 and equal. And that didn't do right, so let me try it again. E, X, Y, 4.63. Yes, and that works. So you see why the estimation can help is if the computer or the calculator is not completely cleared out, it can calculate off the previous calculation. So you want to make sure you clear it really well in between calculations, and you also want to make sure you kind of know about what to look for. So you can get there by either pressing the 4.63, putting in the exponent and hitting the e to the x key, or pressing e, x to the y, then putting in your exponent and hitting equal. It gives you the same answer either way. So if you have that E key and you don't have this key, if you have the E and you have this, that's great. If you have this, then that's great also. So that helps a lot. All right, and let's look at, we have two more. Let me clear the page and set those up. All right, here's our last two problems for lesson 67. So the first one just says write the value of E to 5 decimal places. Well, if you have the E key on your calculator, it's really easy. You just press the E key and then you read off to 5 decimal places, which is going to be 2.71828. So 2.71828. And if you don't have the E key all by itself, then you can type in E, hang on, 1 is the exponent, then the e to the x, and then it gives you the value of e. So the exponent of 1 will give you the value of e if you have the e to the x key, which is the same thing that we just found out, 2.71828. All right, that one was pretty straightforward. So now we want to estimate the antilog of e to the negative 3.2. So this is going to be the answer with a base. So what we want to write is e to the negative 3.2 is what? This is going to be our antilog. That's what we're looking for. So in order to do this, we have to take care of the negative first. So 1 over e to the 3.2 is equal to whatever that answer is, that's what we're looking for. So we're just going to pull up our calculator. And we are going to, I'm going to type in 3.2 as our exponent, and then hit EX. And we get 4.5325. Right? So let's stop it at precision of 2, so 24.53. So that's going to be 1 over 24.53. So now we can divide that. We clear that. We're going to say 1 divided by 24.53, and we get 0.040766. So let's do a precision of, let's just do 4 decimal places. So we're going to round this up. So that's going to be 0.0408. That's enough precision for that. All right, so that would be how we would find the answer to something like this with a negative exponent on the e. First solve it, flip it, solve it, then divide it, and then you'll get your decimal value. And I will tell you on each problem what precision level it needs to be at, because as we discovered In our solutions manual, it gives us different precision levels for each problem. I'm not sure why it doesn't have a standardized precision level for the entire curriculum, or at least different applications. When we do an analog, do this. When we do a logarithm, do this. When we're doing whatever, do this. But it doesn't do that. It doesn't tell us that convention at all in the book. It makes us guess what precision level we're doing. So I'm going to tell you with each problem what precision level I want the answer in, so that you come closer to actually getting it right. I think that's going to solve that problem. All right, that's all we had for lesson 67. Not hard, just learning a new term and how to use it. And that's all we have. I'll see you in lesson 68.